Now we will discuss the binomial distribution, binomial probability actually. A binomial mean it gives two outcomes, right? By mean in English we use for two binary numbers, one or zero, binary, bicycle, right? There are two wheels, bicycle. The mechanics of binomial probabilities. Binomial process, a Swiss mathematician, his name is called Bernoulli. Bernoulli, he's a scientist, mathematician in Switzerland. He has introduced a concept that has only two outcomes. Always there are two outcomes. For example, when you toss a coin, you may get two outcomes, head or tail. When you set for the exam, you can get two outcomes, pass or fail, right? Good or bad, success or fail. There's only two outcomes, rainy day or not rainy day, day or night, AM or PM. So there are two outcomes. The Bernoulli process. So Professor Bernoulli has introduced the concept. Therefore, they have used his name for this kind of trials, experiments. The Bernoulli process is an experiment with two outcomes. The experiment always has two outcomes. That is success or failure. Success or failure, I will explain what do you mean by success and failure, where probabilities remain constant across independent trials. For example, when you toss a coin, always the probability equal 0.5 for each outcome, head or tail. Every time you will get head or tail. The probabilities remain constant across the independent trial. The binomial distribution provides a mathematical foundation to calculate the likelihood of a specific outcome across multiple trials. There are some conditions. I use the PDF, the book, the textbook. Here you can see a Bernoulli trial, an experiment or process that produces only two possible outcomes is called Bernoulli process. For example, in manufacturing process, an item produced can be either good product or defective. There are only two outcomes. The machine outcome may be good product or defective product. Two outcomes. In a firm, attendance of employees can be marked as present on that day or absent on that day for work. So two outcomes. In general, one of two outcomes of a Bernoulli process can be called success and other can be called failure. We can give any name: good, defective, present, absent, head, tail, pass, fail, right? Day, night. Any outcome, maybe any two outcomes. In that instances, we can classify. The Bernoulli classifies the outcomes success, failure. We will label success or failure. If you expect an employee absent, so that instances you are considering absent. Therefore, you have to consider the absent as a success. Present, you have to consider as a failure. The same context. You expect employees present. Then you have to consider that present as success, absent, failure. If you expect head when someone tosses a coin, then The success is head, failure tail. But if you, in the same kind, if you expect tail, success is T and head is failure. It's based on the context and concern. In Bernoulli process, if the probability of each outcome is constant, the thing is irreported. The probability of each outcome is constant from trial to trial. Then the trial are identical. Also, the repeated trials are independent. I have already explained what is identical, what is mutually exclusive events, independent events. I have explained in the quantitation sections. Let's move to binomial probability distribution, BPD. Binomial probability distribution. We apply this binomial probability distribution when we have only two outcomes. Only two outcomes. In Bernoulli process, if the probability of success in a single trial is P, right? The probability of success is P, and the probability of failure in a single trial is Q. Then the probability of R success, how many times you will get success, is called R. And in the n trials, so the equation is this: probability of R success is equal NCR, n number of total outcomes, and what is your number of trials, and R number of success, P probability of success, R, Q probability of failure, n minus R. Here R always get the full number. It's a discrete probability, not continuous probability. It's a discrete probability distribution. And here NCR, how do we calculate NCR? It's a combination, not permutation, it's a combination. We use this formula, right? N factorial, R factorial bracket, N minus R factorial. And remember, P plus Q, the probability of success, probability of failure always equal to 1. You have to remember this one, right? For example, here to explain this formula, you have a coin. Say the coin tossed 5 times. The coin tossed 5 times. Then how many times you can get head? First time head, second time head, third time head. Likewise you can get head. So if you guess head, if you win, success. So in each toss you have probability of 1/2. So P equal 1/2. What's Q? Probability of failure 1 minus 1/2 equal 1/2. And here how many times the coin tossed? That is n equal 5. And if you expect in the in this trial you expect 3 heads. What's the probability of getting head? 3 heads. So that's mean R equal 3. We can also write the probability of R success equal NCR P R 1 minus P. 1 minus P equal what? Q. Yeah, Q. P plus Q equal 1, no? Then Q equal what? 1 minus P. So that's what is given here. 1 minus P and N minus R, since P plus Q equal 1. The probability distribution given by PR when R takes value 0, 1, 2, 3 up to N. For example, here 0 mean no head, no success, only 1 success, 2 success, like that. is called the binomial probability distribution. We can also have, right, the sum of probability R equal 1. Always you have to remember these rules. When we can apply this binomial probability distribution, there are some prerequisites. Binomial experiment possesses the following properties. Number one, the experiment consists of n repeated trials. There should be not only single trial. There are n number of independent repeated trials. Repeat. Number two, each trial there are only two possible outcomes. Only two possible outcomes, referred as success or failure. It may be in any form, success or failure, pass, fail, plus, minus, yes, no, present, absent. The probability of success denoted by P, and in each trial remains constant. This is very important. The probability of each trial remain constant from trial to trial. It does not change. The repeated trials are independent. First outcome is not dominate the second outcome. Note that binomial probability distribution is a discrete probability distribution. It gets only pre-specified values. And the formula, so there are two things, mean and standard deviation of a binomial probability distribution. To calculate the mean, it's very simple and straightforward. N number of trials into probability of success. Number of trials into probability of success, where N means number of trials, P probability of success. Standard deviation, N number of trials, probability of success, probability of failure, and get the square root. That's standard deviation. Now we will work on an example. A pair coin tossed 6 times, then now n equals 6. Considering the binomial distribution, why? Because we call them as a binomial distribution. It has only two outcomes, head or tail. Find the probability of getting exactly 3 heads. Here R equal 3. We know the probability of getting head is 0.5 or 1 over 2. So therefore P equal 1 over 2. And what's the probability of Q? Q equal 1 over 2. Let's see in the formula, right? In the formula, probability of R success equal NCR and P R Q n minus R. Here n equal, right, the coin repeated, tossed 6 times, and we expect 3 head. Probability of getting success, probability of getting head equals 0.5 and R equal 3 into probability of failure 0.5 and 6 minus 3. Then what's the answer? How to calculate? How do we calculate? Can you calculate what is the value of 6? This portion. Tell me. What's the value of this portion? What's the value of that? What's the value of that? Yeah, I can see, I can show, I can do it in Excel sheet. Yeah, n equal 6, r equal 3. So NCR equal 20, right? NCR equal 20. So I can write the formulas. Yeah. NCR. So binomial distribution. Here NCR. So we can get here NCR this value plus here I can put PR and QR. Here PR, you know that 0.5 to the power R. What is that R? R is 3. So I can put P here, P equal and Q equals. P 0.5, Q 0.5. This means 1 minus P. That is always Q. And PR, P is here and power R is 3 and QR, Q is here and n minus power n equal 6 minus R equal 3. Right. Now we can see the binomial probability distribution of exactly get 3 heads equal 20 into 125 into B9. Or 31.25. 31.25. Let's check the answer. At 5, the answer is given here 5 over 16. Let us check it. 3, so 5 divided by 16. Okay, we get the exactly same answer. Okay, we will apply this as well. Instead of 0.5, we can use 1 over 2. Should be down, right? 1 divided by right. And the second question, at least 5 heads. At least 5 heads mean what? At least 5 heads. When we toss 6 times, when we toss a coin 6 times, maximum we can get 6 heads, right? But the question is here, what's the probability of getting at least 5 heads? At least 5 heads mean we win. If we get 5 heads, we win. If we get 6 heads also, we win. So that Accordingly, we have to use or logic. So or logic means we have to add these two. Here, what's the probability of getting 5 heads? Probability of getting 6 heads. Let's see. Probability of getting 5 heads equal here n6 r 5 and p, you know that p pi q 6 minus 5 equal 1. We know that p equals 0.5. Let's apply this into the Excel sheet. Now NCR, right, now N6, now R5. And P probability, no change, 0.5. And it is also, we know, an NCR equal 6. And probability of success is what? 0.5. P minus R. Okay, fine. And the probability of probability distribution function of PR is this is 0.09375. Now let's see probability of 6 by 6. And here we have to change this one. And we will get probability 0.015625. Then we add these two together, right? We add this together, we will get this value plus 0.09375 equal almost 11%. Now let us check the answer. At least 5 heads. Probability of getting at least 5 heads. So we need to calculate. We win if we get 5 heads. We will get 6 heads. Both instances we are win. So here the answer is 7/64. 7/64. Let's see. 7/64. Right, we are getting the same answer, 7/64. Right, 7/64 equal 10.975. Clear? Is it clear? If you have doubt, please stop me. You can apply your calculator, or I encourage you to use manual calculations, since we can use the factorial. You can use, but I don't have calculator. I don't have software calculator to show you the screen. I have no license, so that I'm doing in the Excel, but you are not allowed to do it in Excel in the examination hall. So I encourage you to use manual procedure. No matter, you can apply calculator function, NCR, NPR as well, no issue. And I encourage you to do that. The third question, at least one head, right, in the 6 tosses, right, the coin toss 6 times. What's the probability of get at least one head? So when you got failure, when you get failure, if you are unable to get any head, you will get failure. It means 0 head. 0 head. This time only you fail. Other times, if you get 1 head, you pass, you success. If you get 2 head, you success. 3, 4, 5, 6, you success. For that, what we have to do is, we have to find the probability of getting 1 head, probability of getting 2 head, 3 heads, 4 heads, 5 heads, and 6 heads. So it takes a lot of time. You know that 0, what are the possibilities of outcome? 0 head, 1 head, 2 head, 3 head, 4 head, 5 head, 6 head. And you know that the sum of all probabilities is equal to 1. Right? You have to calculate the probability of this. Probability of all these. That's a shortcut. If you find the probability of getting 0 head and you deduct this probability from 0, probability from 1, you can get probability of this. Here, what's an n number of trials are 0 hit, probability of 0 probability. Then NCR 1, right? It's so probability is 0. You can get 0.0156. What is this? Probability of getting 0 hit. Then 1 minus probability 0 equal, you will get what? Probability of getting at least 1 head. Probability of getting at least 1 head. So simply 1 minus equal 1 minus this value, you can get 98%, 98.4375%. Let's check the answer. It's probability of getting at least 1 head. So it's the formal way is what? Find the probability of this 1, 2, 3 up to 6. But here we can see the we can get this value using the shortcut. For that, we get 64, 63 over 64. Let's see. Let's verify the answer. 63 divided by 64. 9 point. Right, both we are getting same answer. Right. Any questions? Any questions?